This is a gimbal camera model that was assembled and analyzed using 3DCS software. As I'm opening the model, you'll see that I must click the Update Model button. This allows the 3DCS data to load and be applied to the CAD. The gimbal camera is initially loaded in an exploded state to show the individual parts prior to the assembly process. The model can be constrained into a build position through use of multiple moves. This model takes advantage of 3DCS's feature-based move, which uses surfaces on each part to connect and build the model. There's also one point-based move that is used to attach the entire assembly to a simulated fixture. Once the moves are completed, I can use the nominal build button to activate the moves and assemble the model. I can also use the separate button to revert back to the exploded view. Another method of building the model that allows for a more in-depth understanding of how the model is being put together is to use the animate feature. Here you can watch each move being activated one by one, and if you have a problematic build, you can refer to this sequence to see at what point the error occurs. The next step in this process of creating the model is the tolerances. The tolerance is used to demonstrate variation of a surface, hole, or pin by deviating the position and/or the size of the selected feature. The tolerances can be seen within these parts as well as the rest of the model. Once the tolerances are applied, when I nominal build and press deviate, we can see how the tolerances alter the mesh, which result in the assembly shifting to fit the new constraints. Each deviation is generated randomly within the specified tolerance range. I can also use the sweep button to show a general range of the deviations, which is best seen at the extended point coming from the lens. The final part of building this model is the measures. Measures are used to analyze key aspects of the assembly to check for deviations that are outside of the required specifications. The main objective for this model is to test the distance and angle from nominal of the camera's lens. This is done by creating measures in the center of the lens to evaluate the distance from nominal in the X and Y directions. Same measures can be added to the point distance away from the lens in order to test the deviation at a greater range. To test the angle, a measure is created from nominal on the lens to the point out in space. Once the moves, tolerances, and measures have all been added, it is time to run an analysis that generates a graph and table of contributors for each measure. Something to note as I scroll through each page is that the top contributor for most of the measures is a tolerance between the hanger and top motor located near the fixture. This is important because it shows how something far away can still snowball into having a huge effect on the end result of your model. So, based on the results, it can be determined that this tolerance should be altered in some way.